All right, here we are, back again. One more time. Your name in the live chat as before. We'll start in about 5 minutes. So we've got 4 people on. Pop your name in the live chat for me. Right, so we've got Iman, we've got Zarif, we've got... Well, it's differential equations. So yes, you're going to be using some integration techniques in there for sure. But it is a different topic. After this lesson, next Monday, we're going to actually be doing further maths on differential equations. So we're going to put aside the blue books for a while. Reba, good to see you. Shing, good to see you. Shing, try and stay in the chat a little longer this time. You know, you realize the only thing you said in the last YouTube video was hello, which is nice, but, you know, a bit worrying. It's not like, it's like, this is already long planned. I know exactly what I'm going to do. It's got nothing to do with the integration. We are going to be doing differential equations into further maths now. It is what it is. Merla, good to see you. Hope you're well. Okay, let's do a couple of things in recap before we go any further, because this is a rough one. This one will be rough, all right? So let's start from the beginning. Just a quick reminder of how you need to submit your work. So submission of work. This is mainly aimed at Zarif, who wasn't here, and anyone else who wasn't late. It needs to be, it needs to be sent by end of today. I don't really mind if that's like, well, I do mind. It'll be better if it isn't 1 minute before midnight, but some people, you know, I don't really care. It's not the end of the world. I've not got the thing on, so it doesn't affect me. End of today. It needs to be marked because everything's coming out of a textbook or a workbook or a worksheet, and that's fine. So you can easily mark it, and as complete as possible. All right. If your work is missing, further proof, yeah, it is. Some of the differential stuff you'll need to know, some of the stuff you won't need to know. But in general, even for like when you think about if you're going to do a career in a STEM field, you need to understand differential equations. I will have a chat with Steve exactly what he's saying for the further modules, but you will need to know some level of differential equations one way or the other. Okay. All right, cool. So submission of work, end of today, has to be marked. And if it's, and just remember, it's being used to give you partially your predicted grade, so it's not a joke. And what I will do is as soon as like college restarts or when we have to start making decisions if college doesn't restart in time, I'm literally going to go through day by day and go, okay, there was work here, it's done to a good standard, and make a spreadsheet for everyone. And if your spreadsheet's got full of gaps, you've missed things, blah, 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 it's not going to look good for you. All right? So that's part one. Part two. What did we learn, and I say this very, very hesitantly, about differential equations last lesson that we need to bring into this lesson? Yes, that's right, Teams PM, absolutely. And it's just merely the idea of solving equations, solving differential equations by separation of variables, yeah? But of course, that covers a lot of ground. It covers how to deal with the constant, yeah? So all that stuff about ln's and e's. It covers all of the integration techniques. That's why I said to when Kelvin said, are we doing integration again? Well, the topic isn't called integration, but you're going to need all your integration and differentiation skills, which is why I taught you all the skills first, right? So like that's all you need to bring in. But when I say it's all you need to bring in, that's a lot to bring in, all right? Okay, cool, let's roll. So what I've got is, I'm going to give you a couple of minutes. You should all have all the textbooks, right? So the page number we're now looking at is page 326 of the Pure 2 textbook. So I'll give you a minute to find that. So page 326, the Pure 2 book. And I'm going to give you fair warning. Even I stuffed this one up, yeah? I mean, not like making silly errors, as in like I find this difficult. So you're going to have to ask loads of questions and you're going to have to say slow down and you're going to have to do all that stuff, all right? Just brace for impact, all right? On the plus side, that is the hardest thing in my opinion. It's the hardest thing in my opinion in terms of the like, you know, the normal A-level content. All right. So if you can handle this, you can handle anything. I'll plug this in. Okay. So Kaisan pops up and says, like, my internet was down. This will happen. This will happen once in a while. All right. Your internet goes down. These things happen. Right. As long as you make it up, like you go back and you watch the video and you get the work sent in as soon as you can. Okay. I mean, if it starts happening, being a regular thing only at 9 o'clock in the mornings on Mondays, that's when I'm going to start pulling triggers on things, right? If that makes sense. So if you tell me next week, having had all the lessons fine apart from the 9 o'clock on a Monday, then there'll be trouble. But if it's like happens once every, you know, 3 months, hopefully we're not doing this for 3 months, you get the idea. Right? Just remember, I'm using my discretion, but I'm also using my brain, yeah? So some of you guys, I mean, like, for example, last lesson, I caught out quite a few of you guys, and when, like, everyone just signed in and then they just put the video off and went off and did something else, just kept it logged in, and I asked them a question, no one showed up. If you do that, I'll mark you absent. All right? Just remember, when it comes to being cunning and untrustworthy, I've been doing this for a long time. All right? Anyways, enough threats. Let's do some work. 326. So 326, I'm going to take you through the example, as always, and then I'll probably have to take you through a few things. I mean, this is going to be awkward. Okay. So the first thing we do is example 27. Am I still going to mark you in? Yes. You're here, but late. I mean, if you do the work, I'll remove the late as well. Because as far as I know, you're telling the truth. I can't prove otherwise. If we do the work, and that's somebody else. Yes. Okay, so that's good. That's fine. Cool. Let's get rolling. So example 27 on page 326. And it tells you the rate of increase of population of microorganisms time t given out. And this is a really classic example of why differential equations are super important, because this is not really a maths question. This is a biology question. All right. So if you're planning to study a science, whether it be physics, biology, chemistry, yeah, then you will be using differential equations. You'll be using it a lot in computer science. You'll be using it a lot in a varied amount, pretty much every single science, anything kind of even remotely sciencey, from architecture to say something like stock trading. You're using differential equations. All right. Not in the book I've got. The book I've got says that dp over dt equals 3p. Yeah, okay, maybe like the PDF copy and the print copy are different. From the book I literally see it says example 27 for me. So if it's example 28 in your PDF copies, my apologies on that. But I'm looking at the paper copy. I've got the print copy in front of me, and it's example 27 in my book. All right, there you go. Have a look. Here it is. There we are. You can't actually see it. Can you see it? Yes, you can. There we go. How exciting. Anyways, next. Part A says, find a model for P. You're using a paper copy as well? Weird. Well, I just showed you mine said example 27. Find a model for P in the form P equals... yeah, okay, Kai-san, don't stress too much about that because it takes a little while to upload. If you do it tomorrow, so if you come back about, say, like 9, 10 a.m. tomorrow, it should be there by then, all right? Thank you for raising that point, because that is a true point. I mean, you're not being out of order there. So find a point P in the form A equals 3t, and saying find A. Okay, or stating the value of A, yeah? What does that mean? It means you need to do differential equations on this side, all right? Differential equations on this thing, yeah? Because you've got a differential equation here, and you now need to basically do the split, separating variables, and integrate. So here we're going to get 1 over p dp equals 3 dt, yeah? Variables separated. Anyone got any particular issue with that, please pop something in the live chat. So if you find that, like, I don't understand what happened from here to there, because that's what happened. This is what I'm supposed to show and find. All right. Can you say so now? All right. So I've got a differential equation that says solve that differential equation, show it turns up like this, find A. And I've said, okay, my first move is to separate variables. If you do not understand what the hell is going on, best to say it now. It will save you a lot of pain in the future. How did you get 1 over p? Because I divided both sides by p. Yeah, so 3p divided by p is just 3. And whatever's there divided by p is just something divided by p. Could I go over it again? Yeah, for sure. For sure. I was going to write it out more neatly anyway. Where are we at? We've got dp dt equals 3p. I'm not going to copy out the questions this time because I want more space anyways. Whenever you've got a differential equation to solve, and that's what it's asking you to do, you separate the variables, all right? I'm just going to finish off the explanation now. I've started it, but I'll just make it quicker. Separate out the variables, 3dt. Yeah, just be aware. Integrate both sides. I mean, that's not going to be particularly onerous. You're going to get LMP equals what? 3t plus c? C for constant. We're going to do stuff with the constant. Yeah, remember the stuff that me and Iman discussed before about things being convenient, the mathematical reasoning why I can just do that. Obviously, to get rid of the ln, I'm going to have to raise to the power of e. So my next line is going to be ELMP equals e to the 3t plus c. Yeah, and that's just going to go p equals e to the 3t times e to the c, which, yeah, we can just say, well, that's just going to be p equals a e to the 3t. Because obviously e to the c is a constant. E to any number is just going to be the number. How do I find it? You substitute the value that they give you. They say initially the population is of size 8. So when t equals 0, p equals 8. And you can just lob that in there. So it follows quite easily that a equals 8. All right, I hope that makes sense to people. Now I'm just going to stop there, and then now is your time to ask questions. All right, this one's going to be another long one. It's going to go an hour, I reckon, because this stuff is hard and it's the first time you're seeing it. So do not hesitate. Don't think you're slowing anyone down by asking questions, because believe me, there's going to be a lot of confused people in this, and that's fine because it is hard. You don't have to feel dumb if you find this hard, because it is. So if you've got any particular questions, pop in the chat. If you're happy to move on, type in move on. And then I'll move on to part B, C, and D. I mean, B, C, and D are pretty simple. Why is P equals 8? Okay, cool. Because they tell you that at time equals 0, the population is 8. So P equals 8 when time equals 0. Why is A 8? That's a very good question. Let's do the maths on that. So that's Reba and Farhan, and then Iman, I will move on. So if I know that P equals 8 when T equals 0, because they tell me at the population when nothing's happened is 8, so no time has happened. Now if I subs those in, I get 8 equals A times e to the power of 3 times 0. Yeah? Okay? And if I'm just going to move that, I'm just going to write it here, because I think you can just about see that. That means 8 equals A, right? Because anything to the power of 0 is just 1. So e to the power of 3 times 0 is just e to the power of 0, which is just 1. So therefore e. I'm aware that my connection is wavering. So yeah, if you lost me for a minute there, yeah, you got it. If you lost me for a minute there, that's my connection. That's on my side. And I mean, it does happen. So just, hopefully not too much. Okay, C and D are incredibly easy. I'm just going to rub this out. C and D are incredibly easy. Because they're just about, can you stick things in the formula? You've now got this formula that P equals 8 A E. Kill yourself, it's not A anything, is it? It's 8 E to the 3T. You can just subs in values. So when it's to the nearest 100, the time at T equals 2, just subs in T equals 2. It's not hard. So it's going to be 8 times E to the 6. I mean, you can handle that. Find the time when the population will be 8,000 times its starting value. So then you do the equation 8,000 equals 8 e to the 3t. So then 1,000 equals e to the 3t, and just solve that using logs. Does anyone need an explanation of how you'd solve that? Happy to do it. I'll wait a second in case anyone does. I mean, you see what I mean? Like, Iman said something very clever last lesson, which says differential equations are like, they cover all the maths. If you think about it in terms of games, this is like the final boss. All the skills that you learned throughout the game comes back here. So logarithms coming back, triggers coming back. Well, you'll come back. Well, trig will come in a minute. Integration, differentiation, all your skills combined, right? So here I'm asking you, can you solve that? If you can't, can you put no? If you can, put yes, all right? Just pop that in the chat box, one word, yes or no. Even Y and N will do. So I need to know whether I need to do that as an example. Yeah? I mean, it's like that, though. And it's doubly hard for you because, like, a normal math student will have 2 years to understand it. So, you know, it starts filtering through your head. You kind of have it crammed in your head super early. And the plus side of it is obviously you finish much, much earlier. Yeah, brilliant. Excellent, excellent, excellent. So we'll move on. Okay, cool. And then part D goes, state one limitation of the model. They like asking these 1-mark questions. It's a bit like, you know, the pulley question last period where they're talking about Xing. Has Xing disappeared again? Have you noticed Xing just signs on and just never speaks again? Right, so yeah, Xing, if you're alive, good, just checking. So you remember those the one that says, why is it a light inextensible string? And you just give the one-word answer, the one-line answer, which is, okay, tension's the same. Here it's just like, use your common sense. A population can't grow infinitely because there's not infinite space, right? This is a model for population of microorganisms, presuming something on a Petri dish or something like that, right? Eventually you'll run out of space. Even for humans, we'll run out of space unless we like start colonizing Mars or something. Yeah? Okay, cool. I'm sorry to say that was the easy example. Now, this is example 28 in my book, so probably 29 in yours, Iman, and it's the one about water in a manufacturing plant, okay? So by my textbook, that's page 327, example 28, okay? And hold on to your hats, kids, because this is going to get spicy, all right? Your internet is not good, same, but mine slipped a little bit. It's generally quite good. I'm not going to cuss it out. It's half decent. It's done, it wasn't really meant to do this as a job. It's just meant to be like a home thing so I could play like FIFA or something. But, you know, it is what it is. Right, I'm going to start this in 20 seconds. You've got time to find question. Network latency. Yeah, I mean, bane of your life if you're playing Call of Duty or something like that. I'm going to start in about 7 seconds, all right? Okay, let's roll. What makes this question much, much harder than the other questions is it comes back to the title I put on this video. You got to make your own differential equations, right? You got to make your own question. And that's the bit I always find kind of awkward as well and difficult, all right? And we're going to be using ideas of the chain rule as well, and you'll see where those come in. Let's read the question first of all. So water in a manufacturing plant is held in a large cylindrical tank of diameter 20 meters. Water flows out the bottom of the tank, okay? It flows out from the bottom of the tank at the rate proportional to the cube root of the volume, okay? So we need to start putting some formulas together, all right? What can we say straight away? That the volume of the water can be given as pi r squared h, okay? And we know here that if you look at the example question, it tells you that the cylindrical tank has a diameter of 20, so it's got a radius of 10, yeah? So that's V equals 100 pi h, yeah? Everyone happy so far? I hope that makes sense now, yeah? So far, so good. 100 pi h. That means we can make another equation. dV dH, which is just the differential of V, yeah, is going to be 100 pi. Nice and simple, right? Just differentiating V in terms of H, dV dH. And this is what I mean about creating your own differential equation. The other thing they tell you is that the water, the volume of water, the height of the water rather, sorry, the volume of water over time, because we're going to need that first. So the amount of water over time is falling proportional to the cube root of the volume. So we've got V equals, or the rate, sorry, my apology, I'm going to change that up again. the rate of change of the volume, dV dt, equals, it's proportional, so we don't know what the constant is, minus C cube root of the volume. Now, who's confused? And I fully get it, while you wouldn't get where the hell that came from. So I'm going to wait a couple of minutes and ask you that. Who's confused as of now? All I've done is take the information that they've given me in the question. They've told me that the water in this is in a cylinder. Yeah? Okay, fair shot. So let me just write down where I got all this from. So this is the line. This comes from the line. It goes, it's a cylinder. All right? So if the water's in a cylinder, the volume of a cylinder is pi r squared h, and they tell me what r is. They tell me the diameter is 20, so I know the radius is 10. This is telling me how volume changes. Yeah? So this is the hard bit, I think. All right? How does the volume change? I'll read out what it says. Water flows out of the bottom of the tank. So how the water changes, the amount of water changes at a rate proportional to the cube root of the volume. So the amount of water in the tank is cube root of the volume. So where the hell did this C come from? What is this C? I mean, I think you might be happy that the cube root of the volume, because they said that in the question, because it's proportional to. It's not exactly the same as. So if they use the word proportional, you're going to use a multiplier. Quick reminder of GCSE. So you said like A is proportional to B. Yeah? You're basically saying A equals KB. Yes? Does that make sense? From GCSE. I don't know if people still do that. Why is it a minus? Because water's going down. Okay? That's a fair question, to be honest with you about. The reason why there's a minus sign there is because the amount of water in the thing is falling. It's not increasing. If I didn't put the minus sign there, the amount of water would be increasing. Yeah? Because this is the rate of change of water. Yeah? So the fact that it's a negative is telling me that the water is coming out of the tank, not going in the tank. All right? Who's still confused? Who's still confused? So what I did was I made two separate differential equations. All right? Why have I done that? Because if I put those two guys together, I can write dH dt equals dH dV times dV dt. And that's, I promised you chain rule, and that's where chain rule comes in. I haven't got a formula from my question that connects H and T to make dH dt. I haven't got one. But I can make one. And that is the skill that you're learning today. I have to make the differential equation myself from two pieces that I actually got from the question. I mean, if you're very unlucky, it could be three. I mean, they might have saved that for further math, but you know, you could be asked to do three. So what's the situation? The question A says, show that t minutes after, so dH dt. And you've got a problem straight away because there's nothing in the question that connects H and T. So what you need to do is make two other things that if you times them together, they will come together to make dH dt. So here we've got dH dV times dV dt. When you multiply them together, obviously the dVs would cancel and you get dH dt again. And that's what you're looking for. So now again, I'm going to ask you a third time. I need this constant feedback from you. All right. Do you understand now why I chose to do those two things? It was to make the pieces, those are the pieces I need to make what actually the question was asking, which is find dH dt. All right. And then in a minute, I'll show you how you can do that. All right. You got it, Reba? Well done. I'm going to hang on for every single one of you because I understand this is baffling the first time. Because you almost like here, they'll give you some words. It's also like make your own question as well as make your own answer. Good. So we've got 4 people, 5 people on that saying that. Okay, cool. And be aware. So please do ask questions now because I'm looking at the exercise and it doesn't hold any prisoners at all. It is ruthless, this one. All right. Okay, good. Cool. So you've seen the theory of it. So let's do it. So we know that dH dt is dH dV times dV dt. Yeah? Great. That means I need to turn this guy upside down. Yeah? I need to turn this guy upside down, I guess. Yeah? And what we're asking to do there is go dV dH is 100 pi. So this guy here, dH dV, I'm going to keep it there and I'm going to write what it is. It's just going to be 1 over 100 pi. Oh, idiot. And dV dt is right. That's all right. So dv dt is already the right way around. So that's just going to be minus, put a time sign there, put a time sign there, minus c cubed v. Yeah? So sorry, c the cube minus, sorry, minus c, that's the cube root of v. It's not c cubed. I copied it out wrong. So you see how that works? I didn't have dh dv, but dh dv is just dv dh turned upside down. So if you times them both together, I'm going to move the camera just a teensy bit so you can see that a little bit easier. Yeah, that's worked out quite nicely. So that finally ends up being minus c cube root of v over 100 pi. And that's your final answer for part A. Yeah? Now, you can tidy that up. Actually, when I say final answer, it says like you want to get that in a certain form because we've got v. So I'll show you how to do that in just a moment. Is that mathematically true or allowed? True-ish, allowed, yes. I mean, again, it's the same problem we have with the chain rule. If you're treating infinitesimals as fractions, that's mathematically awkward. But do we do it? Yeah. I mean, it's not something that we frowned upon. It's not something we look at you and go, oh my God, what horrible thing have you done? It's just like, it's fine. Okay? Amazingly, part A is still not done. We've done a good job so far, but it's not done yet. All right? I'm going to show you what to do next. So can I give you a minute just to copy that and we'll finish it? Because it doesn't actually ask you for that. It asks you for most of that. But you want it in terms of H, not V. Okay? And we're going to have to deal with that in just a moment. All right? So for the time being, just copy out step by step. As you're copying it out, can you write down why each step is true and why you're doing it? Because when I'm going to like shut this video off in like probably about half an hour, you're going to have to deal with these all by yourself, right? And there's not going to be anyone there to tell you, oh, you better do this line, that, the next line, right? You're going to have to figure this one out yourselves, right? So if you write down line by line what the hell you're doing, it's going to make your life so much easier. Okay? And I'll give you about a minute or two to do that. You do need a bit of time on this. So right now we're halfway through question A on exercise, what is exercise 28 for me, example 28 rather. And I've got to dh dt equals minus c times the cube root of v over 100 pi, and I'm nearly there. I've nearly got the answer, but my answer that I want from the textbook is the textbook question is saying, make it in terms of h, not v. And that's a problem. We're going to have to deal with that. As soon as you finish copying, can you pop something in the chat box to know? Let me know that we're done there. Okay, so as soon as you finish copying, pop something in the chat box. Once you've all done that, I'll finish off part A. We'll look at B, C, and D. Okay, thank you, Reba. Brilliant. Superb. Okay, cool. So this is all vanishing now. So we're now in the point of the question where we've got dh dt is minus c times the cube root of 100 pi h. Now, where's that all come from? I've now replaced v with what v is, and we've already decided that v is 100 pi h in previous working. Check your work, you'll see it there. And that's all over 100 pi. Now, what I'm going to do after that is quite simple. I'm going to say to you, well, I just want the cube root of h. So I'm going to break up that cube root and go, that's minus c. That's the cube root of 100 pi. That's all over 100 pi. And that's going to be times the cube root of h. So that thing there, that huge monstrosity from here to there, is the k they're looking for in the question. And done. Okay? So yeah, k is minus c times the cube root of 100 pi over 100 pi. Which, I mean, I suppose you could simplify to some extent, but I don't see any particular value in doing it. Okay? Why that part specifically? Because the question tells you it's going to be minus some number times the cube root of h. So what I did was I pulled the cube root of h out of the surd and just said everything else must be k. Because literally in the question it goes, show that t minutes after the tap's open, it'll be root h times something. And I've gone, okay, there's your cube root h. That must be the something. And that's just the logic of it, yeah? It's telling you to write it in that form, something times the cube root of h. Then everything else is the something, all right? I hope that makes sense. If it doesn't, again, pop it back in the chat box. I'm going to do B, C, and D. I'm going to stay on for quite a while today. What might happen is I might not do a huge one today, and then maybe on Thursday recap the ones you can't do, and I suspect there'll be a lot of them. But I'm going to be around for. It's not going to be like a short video. This one, fair warning on this, right? Is anyone still unhappy with this rebut? I'm presuming you're okay with that, so I haven't said anything for a little bit. Okay, cool. I'm just going to hold on for a few more seconds in case anyone wants to put anything in the chat. Then we're going to move on to B, C, and D on example 28. Okay, brilliant. Okay, cool. So here's what we're going to do. Let's have a look at part B. It says, show that general solution to this differential equation may be written as h equals p minus qt to the power of 3/2, where p and q are constants, right? There's two things that could happen. One of them is you try and integrate that guy. Done. Yeah, just done. Because it's not even that hard, but it's just awkward, right? They've already told you that it can be written in a certain way, all right? So let's vanish this for a minute. I mean, you've all got it, I presume. We've been told that this can be written in the form k root cube root of h, yeah? So it's show that you can write h equals stuff. It's a general solution of the differential equation. We separate our variables as before. So 1 over h, cube root of h will be minus 1/3. But I'll write it as that for the time being. dh equals minus k cubed dt. Yeah? I hope everyone's happy with that. So it's not, I keep writing as cube, which is not. It's just minus k, isn't it? Because the cube root is on the h, not the k. So you've got this. That's what you've got. All right? Everyone reasonably happy so far? So it's asking me to solve the differential equation, so that's what I'm doing. That's h to the minus 1/3. So when I integrate that, becomes what? 2/3 power. Yeah, it must be 3/2 then. So 3/2 h 2/3 equals minus kt plus c. All right, it's just integration, straight integration, nothing else. And then it's not even that bad after that. If you get rid of the 3/2, what do you get? Yeah, you get this, don't you? So you get h 2/3 divided by 3/2 same as times by 2/3. So minus 2/3 kt plus 2/3 c. So that seems okay. Seems fair enough. And then finally, obviously, get rid of the to the power of 2/3. That's the same thing as timesing by what? 3 halves, I guess. Yeah, 3 halves would have to be the one. So then H equals minus 2/3 KT. I mean, this one isn't even that hard. It's just like you've got to use tons of stuff. Right, I'm going to leave that there as a solution. And I want you to pop in a chat box what bit confused you, if any, right? So have a look at part B. This is how I've done part B. Literally, all I've done is integrate it and tidy it up so it looks like what they want me from part B. Then we've got part C and part D to go, but I need to hear from you before we go any further. Was there any line on that confused you? Right. I missed C. Yes, I did actually. Quite right. Yep, you're quite right. Fixed now. Anything else on that particular part of part B? And again, it's rearranging inserts from year one. This is what I mean about final boss of all mathematics, well, at least A-level mathematics. Because you're literally going back to your GCSE and A-level content on surds and indices and powers and all that stuff, all that good stuff. Every school you've got can be examined by differential equations, why I like doing them. Because it forces you to know everything. If you don't, you need to say so I can help you out and explain, well, why is this thing true? What's next? How many marks is this question? I mean, they can go up to 13 to 15, I would say, for this whole thing. Which line is the 3 halves in? This guy here is a power to that bracket. Thanks for asking. It's a fair shout. Any other questions? Put either, as in the 3/2 on the left, it's on the 2/3. So it's on this line. So it's on the H there. So it's 3 halves H to the 2/3. Thank you. Thanks for asking. It's a good question. Anything further on this? So can we put either move on or still confused? Whichever one you prefer. That's fine. What's today's date? 27. Anyone else got anything else they want to say before I move on and finish the rest of this question? It seems to be ominously silent. Okay, if you don't answer in the next like 10 seconds, I'm just going to move on to C and D. Can move on. Thank you. Okie dokie. What do we have here then? Find the values in P and Q and find the time when the water is at depth 1 meter. They also give you some new information. So initially the height is 27. So what does that even mean here? So when they give you some information like initially the height is 27, it means that at H is 27 when T equals 0, when T equals 10, H is 8. All right? So that's what that means. It just gives you coordinates you can plug in. You've got for part C, what can we do? Probably the easiest one to go is probably just best to go like this and just go, well, look, H to the 2/3 equals what did I call it? I'm just trying to look it back up again. Minus 2/3 kt plus 2/3 c. Just to be absolutely clear, this guy is your q, and that guy is your p. Now, all you need to do is substitute these values into there to find q, and then you substitute, or you can also substitute the other value in there to find p as well. So that's how you find p and q. I'm not going to spend too much time on that, so I think that's a relatively simple concept to grasp, all right? I mean, I suppose the hardest thing in there is deciding which one's p and which one's q, but they tell you straight away that q's the ones that's timesing the t, all right? So the minus 2/3 k is the q. In fact, actually, to be fair, the 2/3 k is the q, sorry, and p is the 2/3 c, all right? And then you just substitute these coordinates into that. That's c dot. Find the time in minutes when the water is at the depth of 1 meter. If you find out what p and q are, and I'm not going to do this because obviously they are in the book. So p equals 9 and q equals a quarter. Q is a half, sorry. We can now fill these into the equation, all right? We can go h equals h to the 2/3 equals minus 90 plus a half. Is that making sense? Okay, because we now know that sorry, it's the other way around. It's a half t, I'll put it here. H equals a half t minus a half t rather. Yeah. Minus, should we go with, yeah, I'm making such a hash of this. H, what's the fastest way of doing it? Let's just do it like this. H equals 9 minus a half t to the 2/3. And we got that from we got that from previous work. We now know what p and q are, we subs in, nice and easy. And then all you got to do is solve that equation when t equals, what's it asking you to do? When t equals, no, when h equals 1. Yes, and put that as h equals 1 and solve that. So you go 1 equals 9 minus a half t to the 2/3. So the way you solve c is write out your equation and subs in your h's and your t's. And the way you solve d is get your easiest version of the equation, substitute h equals 1 and solve for t. All right? What I'm going to do is I'm going to hang around for a while this time. All right? So I'm going to hang around for about 20 minutes on this stream. I want you to do as much of it while I'm here on YouTube as you can. All right? So start on 11K. Yeah? You know where you can find solutions from. But what you need to do is be very, very open that I don't get this, I don't know what to do, etc. So start on page 328. All right? Page 328 is what you need to start on. Exercise 11K. So it's 11K, page 328. I am going to hang around for about 17 and a half minutes. Make it 1 hour exactly, this video. All right? This is your chance to ask me questions on this topic. All right? I will also start next lesson on this because I feel like you will need at least 2 lessons on this content. All right? So you know what you're doing. Exercise 11K, page 328. I might not be saying anything, but I'm going to stay on for about another 60 to 70 minutes to give you an opportunity to ask questions in the chat. All right? So don't panic, I'm not going anywhere. So if you've got any questions, just pop them up in the chat. Even if I'm not saying words, I'm here. Yeah? In fact, what I'm doing is actually waiting for questions. All right? Do we need to submit 11K by today? I'd like you to do some of 11K by today, not all of it. I reckon we're going to need another lesson on 11K. But I'd like to see maybe at least 2 or 3 done, just to show that you've learned something in this first. I reckon we're going to do another lesson on it, realistically, on Thursday. But that doesn't mean I want no work to be done now. I want to be able to see that, you know, something's happened today, even if you got them wrong. That's fine if you get them wrong as well. Don't worry. First time I saw this, I was like horrified as well, quite frankly. It's awkward as hell. So yeah, you're not expected to submit the entirety of 11K today. It should be done by the end of Thursday. But I want a bit of 11K done, just for you to see for yourself, do I understand what the hell's going on here? All right? What was I going to do? I was going to send an email out. Okay. Yeah. Yeah, I mean, send what you can, marked as well, yeah? Those people that want a Kahoot, by the way, there will be one, but it'll be at 1:15. So if you're around, check this channel. I'm going to do a Kahoot. It will be on, guess what, integration. And it'll be with my year 13s. So if you're bothered, hang around. I mean, not hang around, don't literally hang around. But, you know, I'm just saying, I did promise a Kahoot, there will be one. The thing about it makes it awkward is I can't stream the whiteboard and I can't stream my screen at the same time. So I have to make a decision whether I'm going to stream one or the other. And there's no way I want to differentiate. I want to do differential equations from a PowerPoint. That would just be mayhem. No one would get anything. But if you're jonesing for your Kahoot, that will be the time to show up. Yeah, okay. You'd have a chance, I think, because I don't think they're going to be super hyped about it. And to be fair, you've gone through integration hell with me. Would you beat all of them? Yeah, you might as well. You've got nothing better to do. If you're fasting, it will take your mind off the fasting, I guess. As I said, you're more than welcome. I did promise you one. I didn't want you to feel like, yeah, he forgot it. I didn't. It's just I didn't see how I could fit it in a lesson. So I thought, okay, you know what? When I have the year 13s on, I mean, like 1:15-ish, I'm going to start doing that. Like, so can you go over question 9? Yep. Are you happy to? I'm going to just pull it up. That's the book flapping. Oh, it's the last one. Lovely. Lovely. Are you happy with the notation, Morella? Do you understand what R0 means? Is it R0 that's hurting you? So the amount of time, what do you think? There's not even an example. I mean, we've just been told to kind of like give them some stuff that's useful to them. So for me, I'm going to teach them like chi-squared, which is something they might do like if they work in business and stuff. You do have a bit of a point there, and there's not much I can do about that, but they've said carry on for a couple of weeks. So next week is their last week, next Thursday. So there's that. What am I doing? I was looking up 11K, wasn't I? It was the one about carbon dating. Okay. Sorry, that's just my phone bouncing off a water bottle. I don't know why you needed to know that, but there we go. Right. I'm trying to get my textbook because I can't hold two things at once without destroying one of them, apparently. Right, let me just write out the question while I'm waiting for it to load up. Fossils are from carbon dating. The amount of carbon decreases over time. Lovely. Proportional to the amount of carbon. Right, cool. So that's nice. I mean, that should be quite two relatively generous differential equations. So the first one is the amount of carbon over time would be dr dt minus whatever constant you've chosen to use. So it doesn't matter if you've chosen a different one. Yes, they've told you that. That's what the first line says. The amount of carbon remaining is fixed, that's that. The rate of decrease of carbon is proportional to the remaining carbon. Okay, you've got to be careful with that one. Now that's the awkward one, isn't it? Got to think that through. That differential equation, I don't actually think I need yet, but I'll get to it. Wait, yeah, fine, go with that. Okay, cool. What they've done in the question, they've come up with something called R0. Yeah, so R0 is just like the amount you have that to start with. Obviously, if you separate out the variables here, it goes quite nicely to becoming 1 over R dr equals minus k dt. So again, ln modulus R equals KT plus C negative. Yeah, seem reasonable to everyone? Hopefully. Exponential both sides, put the power of E, and you get R equals e to the minus KT plus C. Yeah? Which is relatively not particularly exciting. I mean, we can all handle that. Nothing very, very difficult there. We're told that T, when time equals 0, we're going to have to check whether you can see all of this, R equals R0. Okay, so that's handy. So that means e to the C is just R0. Do I need to explain how that works? I'm going to shut up for a bit and have a look at the live stream and see what you're saying. Do you understand part A? What's R0? So R0 is literally the amount of carbon you have. So I just realized you cannot see half of that working out. Ugh, annoying. Yeah, there we go. So basically, what it's saying is when time equals 0, the amount of carbon is R0. That's the name of it. Yeah? And that's all it is. So you get to this point and you go, well, okay, this thing here is just R equals Kate. Oh, kill yourself. Sometimes you're so stupid. E to the minus KT times by e to the C. At time 0, that's just going to be 1. So that means if R is R0, then R0 has to be e to the C. Yeah? And we know that that just becomes an A anyways. All right? They got it easy compared to you. I mean, if you are going to come and take part in a coup, that's not an opinion you should share, because I think they'd hang you by your ears, possibly. I think it's totally unfair on them. And because I can't really talk about how the system's going to work beyond what Off-Qual put out, but I feel so sorry for them. They've definitely had it far, far worse than you. Whatever's happening to you, you can fix, right? Maybe we're back in college in June. Maybe we're back in college in September. Whatever happens, we'll do more booster classes, we'll do more work, we'll get you through it. Fine. They don't get a second chance, right? Well, they do. But the second chance is after lockdown, straight away, go and do some exams. They're going to get battered. Or waste a year of your life. Yeah? Trust me, their life is not easy mode. I'm not saying your life is easy mode either. Bad stuff has gone down for you as well. But like, they've had it worse than you. Guarantee you that, right? Because literally, imagine it's not quite this. Good one, Amira. It's not quite as bad as this. But if you look at how it's meant to work, your results are basically based on how well your teacher rates you. How subjective is that? I mean, there is this. By this point in the year, they were just about to do their first proper mock exam, full mock, right? So we did like shortened mocks, So they never really got a full-on chance to try out everything. I mean, it's not quite as simple as I'm making out. It's not literally VJ says, I don't know, person X gets an A star and that's how it works. It's not that simple. I can't talk about it. But there is an element of that. How would you feel like having that teacher you don't like? It's probably me, to be fair, in this class. I mean, I know I love you about as much as you love me. But like, how would you like having your life in my hands? I mean, to be fair, you should be right with it. It's like, I don't take grudges into black professionalism, right? So if it does come to I'm predicting your grades will be done absolutely fairly. Absolutely fairly. But the point of the matter is you wouldn't feel comfortable. Do you know what I mean? And you might feel, and to be fair, it could go the other way as well. I mean, it might be your favorite teacher, but your favorite teacher has to predict you a D because you're not good at their subject. It's just so horrible. The whole situation is so horrible. Give people exams because exams are fair. Is what can you do? Do you know what I'm saying? So whatever you're saying, I do feel bad for you. I think you had a rough time. You have had a rough time. You've had it second worst compared to anybody. But it's a 13's who had it worse. That's my call anyways. And of course I miss those guys as well. You know, I'm very fond of them. I mean, don't feel guilty because you know what? It's not like what you're going through is easy. I mean, this isn't like easy for you at all. I get that. But the thing is, do you know why I feel comfortable? If I'm teaching you next year, I know I can do extra hours. So like I'll do lunchtime classes, I'll do booster classes, I'll do all that stuff for you. That's not a problem. So in my head, I'm already ready for that, right? And I also know, as much as I hate you guys, and sometimes I do, I know you're hardworking and I know you're clever, all right? We'll get through this. We will pass. You will. I guarantee you that. You will pass. You will pass well. But it's the other guy. It's out of my hands now. Do you know what I mean? I can recommend that person X gets an A, but then it's going to be down to the government when it gives it. Yeah. And then the other side of it is, what if it's my opinion that a student that you're very fond of, you wish all the best to, gets a B and a C. If I don't get the GCSE grades that I need this summer, can you imagine what happened to me? I don't know what's happening for GCSE. I suspect it's going to be the same format as the A level. I don't know what your predicted grade is going to be. I can't speculate on your predicted grade. I wouldn't worry. If you've shown and to be fair, Iman, you're the prime example of this. You've worked hard all year. Yeah? Your teachers have seen that. I don't think you need anything to worry about. That's not me secretly saying you're getting an A star. Let's be clear. So I cannot give any hints on any of those lines. They have strict policies on research. But the thing is, you did it in college. You did it with Hope. So Hope has seen you working. So Hope can give a fair opinion on what you're doing. And if Hope can't, she can always come to either me or Steve, and we'll say, yeah, obviously. Yeah? We've seen you working doing maths, right? So I wouldn't worry. The worst one, the absolute worst, even worse than year 13, is the people resitting year 13. So imagine if you're resitting year 13, you failed year 13, or you didn't get what you want, so you got B's instead of A's, you want to go Cambridge. And this is someone, I'm actually talking about someone in real life, this is. Oh, I see. I don't know. I wouldn't stress too much in the two reasons I wouldn't stress too. I mean, it's easy for me to say. Like, he's got all these qualifications. Of course, he say don't stress too much. Number one, I know this is kind of harsh, but true. There's nothing you can do about it right now. Yeah? Okay, that's going to be interesting. I mean, don't worry. As I said, they know you exist. You've been entered for the exam, so don't stress too much. There's nothing you can do about it right now. There literally isn't. And the second thing of it is, one thing, I don't know any single teacher. I'm not saying this to make you happy. God knows we fight like cats and dogs. But I don't know any teacher, and that includes me, that will say, oh, Iman doesn't work. Because that would be a lie. Iman does work. Iman gets it. Yeah? So I would not stress too much. You've given your best foot forward for now. What else can you do? The only thing stress is going to make you feel worse. So you may as well just go, okay, I've got my studies that I'm going on. Are they still teaching GCSE English? You're struggling on two. Oh, we've got a few minutes. Let's have a quick look. Give me, I'm just flicking through the pages. Right, here we go. Okay, 11K. So given that okay, so what they want you to do first is integrate the damn thing. And that is it's the worst thing in the world. Yeah, I don't know what they're doing, all right? And it's the honest answer. If you want me to find out anything, I mean, within reason, you've got to be careful with this. I can't break any rules at all. I'm not going to. But I suppose you may want to email them and just see what's going down with that. Are you going to be okay with it? So that's the MDT. Put that on the other side. You've got 1 over m, 1 minus m. I'm just looking at this, and that's just what 1 dt. Do you know how to integrate that, Kaisan? That's algebraic partial fractions. Why do you integrate? Because it says find an expression for m. Yeah? Find an expression for m. And right now you've got an expression in terms of dm dt. And you might go, well, I've got an m there, BJ, what are you whinging about? But that's not what they want. They want m equals stuff. So that's what you need to integrate. Okay? I hope that makes a bit more sense to you. Just to give you heads up, so that would become a plus m, b plus 1 minus m, and you have to find out what a and b is and integrate and all that stuff, right? So that's what you do there. The other side will just be t dt, all right? Once you've got yourself an equation, then you can substitute in to find out, what am I trying to find out here? So basically, you substitute in there and you'll find out what c is, because there will be a c in this. So you integrate this guy, you integrate that guy, you get t plus c, and so on and so forth. All right? And c is what you're trying to find. All right? We've gone up to about an hour, but I'll hang around for a little longer. There still seems to be questions being asked. If you are done here, you are free to go. This is not like, you do not need to be here if it's not relevant to you, or if you want to go away and practice. So English is fine. No one knows what happened to teach. That is true. That is fundamentally true, man. I've got kind of a better idea than I had 2 weeks ago. I'll say that. But if you point at one of my year 13 students and say, VJ, do you know what A-level result she's got or he's got? I could not tell you. Not that I couldn't tell you because of the rules. Obviously, I can't tell you because of the rules. I couldn't tell you what they're going to get either. So, yeah, just we've never had anything like this before. A lot of stuff's being made up as we go along. All right? I know that's not a comforting thing or something you want to hear, but it's true. Nobody really has a full plan. Like the government, if you're watching the news, and I hope you are, the government is like on being pressured to what's our get out of lockdown plan, and they haven't got one. So even the government, they could not tell you, like in 3 weeks' time, are you going to be able to walk the street again? Other than obviously going to like shopping or whatever. So like, I understand why you'd worry. I fully get that. To be honest with you, I fully understand why you'd worry. Tory is trash. I mean, they haven't done as well as they might do. I think Boris Johnson said the right thing today in that he said it's not time to release the lockdown. I want to get out so badly you can't even imagine. Trust me. I'm so bored at home. But it's not time yet. Maybe in 2 or 3 weeks. I hope. Fingers crossed, right? Maybe also like him nearly dying will help him, think a bit. Be a bit more thoughtful. Because he kind of took it lightly and then he got it and then he nearly died. That's the kind of thing that will change a man. You know what I mean? So there's that. We were back to school on 11th of May. I mean, if I had to guess, I'd say June. I wouldn't mind if it was June. I'd like the lockdown to ease up a bit. I'd like to be able to walk more than 500 yards from my house without, risk of being arrested. I don't think we're back in May. I think we're back in June. I think we'll have maybe 2-3 weeks in June. In those 2 or 3 weeks, we're just gonna get everything sorted again. You know what I mean? Like get back on track so everyone knows what they're doing. Remember, I told you there's going to be no proper mock exam before September. It'll be good to have you guys back in the classroom as well. Because, you're going to come back and it's going to feel so weird. I mean, for the Muslim guys, I hope you guys get Eid without lockdown. That'd be nice for you. I mean, there's a chance. You might not be schools back by 11th of May or college back, but I reckon at least you can see your family. That'll be nice. I don't know if that's going to happen. That's in God's hands. Well, I said that would just be year one stuff, yeah. Your September mock's going to be super easy because I don't reckon it's fair to predict your A-level maths by giving you harder work than the normal A-level maths. So literally, it's just the year one stats and the year one thingy that's going to be considered. Your further maths, on the other hand, will have stuff that I've taught you. So just by the by. So you have, I don't know what Steve's going to do, but I'll talk to him. So you'll have stuff like integration and all that stuff in there. Because you need to know it for further. You need to know it for normal as well, but it is what it is. So I mean, I wouldn't start cramming for September. I'm also worried about my step. Now that's a fair shot. What you can do, let me have a chat with, I want to talk to Mark tomorrow and see if he's up to kind of live streaming a bit of STEM. No, I get that. When is step? Is step near the A-level time, the exams, or is it September, October? Because I know one's early and one's late. I can't remember which way around it goes. You've learned most, yeah, you have. The only thing you haven't really, one of the things I'm going to do at some point is give you a proper year 13 paper to see what you've done and see how comfortable you feel with it. I reckon, no disrespect, you get back, this happens every time, you get better the first time and you get better and better and better. That's why I'm not stressing about differential equations. I reckon, you're going to get stuffed this time. It's fine. When I was young, I got stuffed the same way. It's hard, you know what I mean? It's not something to stress about. Matt is earlier, so you'll fail. Yeah, but if you fail, so what? The only one you have to worry about failing is the one that's in 2021, right? If you fail every single one of your mock exams, well, actually, don't fail too many because you want UCAS grades good. But do you know what I mean? The only thing you have to do is understand it by the end, right? As long as you're making progress, that's the thing to watch. And you need just to stick with the working because there's obviously, my biggest concern is people are going to start, getting bored. Every Monday is going to get harder to wake up for 9 a.m. I mean, today it was yeah. It is what it is. It is what it is. Right. Let's see if there's going to be more questions. I'm going to hang around here for another minute or two. Just got to send out some emails. There's no point me kind of running away from you. I'm not going to go and actually do something. Hello. We got what's up? Have you say? Boom. There we go. Got that open. That's that done. Boom, boom. Where are you? Ah, there we go. Live stream. One more question, moments. Since we're not really to do work. I mean, this is the concern, isn't it? The thing for you is like the year 13s, if they're not bothered, well, you know what? They're gonna get a grade. I honestly don't know how this government can be. They could literally just say to you, we're going to do the exam the same standard as if you're in class, because you know you have, to be fair, you've had lessons, haven't you? I mean, it might not be in a classroom, but you know what I mean? Your life hasn't stopped. Do you know what I mean? Your mission isn't complete. You kind of have to push on to explains what types of value of M as T increases. As time increases, does it go down? I'm just going to check that. I'm just looking at it in terms of the rate of change. Yeah, so I'm trying to find the bloody things while I can help. Sorry. M approaches what? Okay, can you pop in the chat box what the equation was? What you got for M? It's an exponential, I'm guessing, right? So if you type in the chat box what M was, I'll be able to answer that question for you. If the worst case scenario, I'll do it for you, but that's going to take a few minutes. Yeah, got nothing better to do, but yeah. Such is life. It might be faster if that's just open. Reply or not save. Okay, let's see what we've got. Okay. Is there? Well, as t goes to 0, as the t gets bigger and bigger, sorry, that becomes really, really big number. I'm going to use the symbol for infinity. I'll go to maths hell for doing it because it's not infinity. But as t gets bigger and bigger and bigger, e to the t gets bigger and bigger and bigger, yeah? It's going to put just tends towards infinity. And then you're going to get 1 plus something that tends towards infinity, yeah? So you've got some really, really, really big number divided by some other really, really, really big number, and that whole thing is going to tend to, I'm going to write it out properly mathematically. The limit as t tends to infinity of e to the t, 1 plus e to the t is 1. Why? Because this plus 1 here just stops mattering. Because these numbers are huge and this number is huge, yeah? So imagine that's like a billion and that's a billion. Who cares about that little 1? It can go and kill itself, right? So 1 billion divided by 1 billion and 1, yeah? Then it gets bigger, 1 trillion over 1 trillion plus 1, yeah? As you know what I'm trying to say. So what I'm saying is, as these get larger and larger, because obviously as t gets bigger, e to the t gets bigger, you get a huge number on the top, huge number at the bottom. The 1 stops mattering at all. It's so small no one cares. And they cancel each other out to get 1. All right, because they're both the same size. So it's basically huge plus 1 over huge. The 1 stops mattering. It just becomes huge divided by huge. 1. Yeah? When people say the word huge, they don't pronounce the H. Like, you know, Donald Trump says huge. Doesn't matter. Not interested in that. Basically, it's just the idea that if you've got a big number and you've got, so I'm not talking about big, I'm talking about tending towards infinity. Yeah? Divided by another number that's tending towards infinity. And they haven't got any divisors. So be careful. If it was this, then it would be 2. No, half, sorry. Yeah? But there's no multiplier. Do you know what I mean? So you've got to be careful. You can't just go infinity over infinity is 1. Because that's, I mean, this is why maths with infinity is awkward. But seeing as they haven't got a multiplier, they're both the same size of big number. All right? So I'll shut up now. Take care, my dude. Bye.